Alright guys, in today's video we're taking a look at a check engine light on this 2013 Chevrolet Avalanche with the 5.3 liter LC9 aluminum block V8. And if we take a look down here at the scan tool and starting our diagnosis of this problem, just going to fire up our Tech 2. We got a candy module. This is just going to take a second to boot up. And then we're going to go in and build this vehicle so that we can, it's a four-wheel drive, so we'll select K, Avalanche, powertrain, LC9 engine, 2-speed automatic transfer case, engine control module, DTCs, DTC display. It's talking to the ECM. Okay, we've got one code. We've got a P0300, just a random engine misfire detected, no other information. So if we want to diagnose this, could be a lot of different things. And rather than just diving into the diagnostic tree and the service manual, let's just see if we can get a head start. So we're going to go into special functions of the Tech 2 and we're going to take a look at misfire graphic. And we can see if we get any information about what cylinder it's complaining about. And so we can see here, we're happy, the engine's happy with 7 of the cylinders, but it's not happy with cylinder 1. So it's not sure why we didn't get a specific DTC for a cylinder 1 misfire here, but cylinder 1 is clearly the one that's racking up the misfires. So let's go take a look under the hood and see if we see anything obvious. Actually, before I do that, guys, let me just show you another view. So this is just the kind of the graph view, but we can also back out into data display and we can see the raw data populating that graph, just for those of you that might want to see what that looks like under misfire data. This kind of information clears out between run cycles, that while this engine is still running, that we've recreated this problem. You can see cylinder 1's just constantly racking up and then rolling over the count, right? So let's go take a look under the hood without shutting the engine down. Alright guys, if we kind of zoom in here on the tachometer, we can see a little bit of jumping here happening during this misfire as well. That's another indicator that you got that going on. You can also feel it. You can feel the engine kind of stumbling when you've got this sort of problem. Alright guys, under the hood here, we're on the driver's side bank. This is the equipment for cylinder 1, the ignition setup, 3, 5, and way back here, 7. So our misfires are happening on 1. And so when we're getting steady misfires like this, so we've got our Tech 2 just propped up here so we can keep watching the graph. Right, so she's still creeping up on the graph and still resetting around. So if we take a look at this kind of a hard fault, we either have a problem with the electronics coming from the powertrain control module into the coil, or we have a problem from the coil to the spark plug, which would mean the plug wire, or we have a problem with the plug itself. This is pretty straightforward. Is it going to be a problem with exhaust being plugged up or something? Can it cause that same code? Yeah, but not for a single cylinder misfire. At most it might be a stuck exhaust valve. But let's not go for the hard stuff. Let's get rid of the easy stuff first. So right while the engine is still running, I'm just going to put an old school spark plug tester. It's one of these kind of guys. Uses a little tube with a rare earth gas in it, like xenon or neon, and it'll pick up on the energy going through the plug wire, and it'll light up this tube by exciting those electrons. So if we put this on the number 3 plug wire down near the bottom here, you can see this guy flashing, so we know there's energy going from the coil to the spark plug. Let's do the same thing over here. Right? So we got the same thing going, although you notice it kind of intermittent. Sometimes it's missing a beat. But that tells me that the coil's not dead. So, you know, before we shut the engine off, we just want to do some basic testing like that, because if we had nothing, that might tell us to go straight for looking at the coil. Because we still have something, we're going to go start from the basics and work our way up. So let me shut the engine off and we'll pick it up when we get this guy cooled off a little bit. Alright, so what did I mean by start with the basics? Well, in some sense, debugging one of these P0300s can be manufacturer and engine specific. So we've got a 5.3 liter RPO LC9 engine. That's an engine with active fuel management, or AFM. And so we know that this is an oil burner. That's just how it is. 2013 model, this many years down the road, that's just where things are at. So we can suspect that that could be causing a problem, right? Because you can get fouling of the plugs, for example. This is also still running on the original coils and the original ignition plug wires, so there could also be something going on there, but less likely. When you grab these things, just grab them by the metal shield, never by the rubber. And when you pull something like this, make sure you don't have the tool wrapped around the wiring harness for the sensor. So the first thing we're going to do is we're just going to inspect the wiring. Right, so nothing burnt on the insulator. Everything's intact. There's no visible damage. Right, so we don't see anything immediate with this. But what we're going to do next is we're going to do a resistance measurement. So I'm going to grab a voltmeter and I'm going to show you in the service manual what the specification is for these OEM type ignition wires, right? So if I look in the service manual here for this model, this is any of these engines, it doesn't really matter. And we go into the engine control section. Down here on the ignition system specifications, what we can see is the spark plug wire resistance is 170 to 220 ohms for basically for every inch of wire. And when they're talking about that, I've always interpreted it to be the exposed wire that you can see, right? So when I say the exposed wire, I mean this wire, right? So a little over 5 inches, right? Technically, you know, you've got conductivity all the way through this boot and all the way in this boot, but I've never expected them to include that in what they want you to look at. So let's see what we've got here. So real simple, we're just going to come in here. Push our spring down and we're going to make contact here. If we can make contact here, way deep inside, might need to get an adapter on my probe here. Let's see. Let's get this in the right mode. There we go. What do we got? 402 kilo ohms. So that is not in spec. Now, is that the problem? No. That's a problem, but that is not the problem. But these are probably at the point where they're in need of being replaced. But it's not an open, so that's not causing our misfire, in my opinion. So the next thing we're going to go do, I mean, it's something we need to go service, but it's not the problem we're after. Let's go after the plug next. Come down here and get a plug socket on this guy. Breaker bar. I think it let go. Yep. Okay, let's pull this out and let's see what we got going on here. All right, so a lot of crusty going on here. Let me grab my little wooden probe that I had here before. Don't know where I misplaced it to. Give me a sec, guys. There it is. Don't want to touch this with anything metallic. But if we zoom in on the plug here, and these are AC Delco 41. I just messed it up there. 162s, I'm sure. Yep, 41 162s. And there's oil on the plug threads, right? So like I said, no surprise, this is an oil burning engine. But if we zoom in here, what I don't like here is like this deposit that we see right next to that part of the conductor. But what I mostly don't like is if you take a look at the gap, this iridium electrode is burned down. You should be able to see a very thin center on that iridium electrode. And that gap should only be about 40 thousandths on a factory plug. You can just tell looking at this, that's not 40 thousandths. Let me see if I have one of these plugs on the shelf here. I might have, I don't know if I do. Let me see if I have one. Come back and see if we can compare it just to give you a better idea what I'm talking about. All right, guys, I've got exactly one of this particular type, but that's all we need. All right, so 41162, genuine AC Delco, genuine GM. Let's pull our guy out of the socket here, and you can see what I'm talking about. Hopefully we'll get under the light here. And if you zoom in, I don't know if it works better to have my finger behind here, something dark. But you can see that center electrode on the new plug, and we don't have that on the used plug. In fact, I'm going to put this guy back in the socket for a second, just to hold him where he's not going to touch anything. And I'm not going to, gap this or anything, but just to again show that we've got a problem here. I'm going to pull a feeler gauge over here, and I'm going to set it to what the factory setting is for this particular plug for this particular engine. Right? Different plugs have different gaps for different engines. 40 thousandths on this guy. And you don't ever want to stick a feeler gauge into an iridium plug. I'll kind of get him over here behind something where you can see, yep. And we're just going to hold this next to it. And you can just eyeball when we're zoomed in. That's like dead on 40 thousandths. Put this guy back in the box. We'll go grab our used plug. We do the same experiment, but you don't have to even stick this in there. Right? Just touching right at the top. You can see there's a massive gap. This is closer to a 60 thousandth gap. So is that the problem? Well, again, that is a problem. Don't know yet if it's the problem. But since we've got this repeating pretty easily, I've stopped the engine and restarted it, and it keeps racking up these misfires. So it'll be a pretty straightforward test. What you could do is we could swap this plug with the number 3 if we didn't have this spare one. Since we got the spare one, and I don't like the condition of this one in the first place, we're just going to put a new one in there and see what happens. But the other thing we can do, all of these ignition wires are the same on this particular engine. And so we could also swap the 1 and 3 ignition wire as some preliminary checks to see what's going on. But for what we're going to do right now, I'm just going to take this new AC Delco plug just for grins. We already know that the old one doesn't look healthy. I'm going to have to block your view for a moment, but we're going to put this guy in, and then we're going to torque him down to 11 foot-pounds. You always make sure you have clear eye shot of the threads, because you don't want to be groping around here and then mess up the gap. And these exhaust manifolds are super, super hot too. But I'm going to get this guy threaded by hand all the way, and then I'll come over here with a torque wrench. And then when I do the torque wrench, we're going to pull this socket off, because we can't use a swivel with a torque wrench. We'll get a bad torque output for that. Grab the torque wrench over here from the tool tray. Set it to 11 foot-pounds. Put that plug wire back on, and we'll see what our Tech 2 has to say. Now, is it this easy all the time? No, and it might not even be this easy this time. But we found a problem, and so we're going to correct it. We don't know if we found the problem yet. So let's go ahead and put this wire back on, even though we know it's out of spec. Make sure you hear it click. Now, We're going to take this back off and put some dielectric on it after we do this test, but for now we're just going to pop it on without. Make sure we hear this guy click up and get back to where the witness marks are. Let's go ahead and fire this engine up and let's see what happens on our Tech 2. All right, so sometimes these will reboot because when you start the engine, you pull the voltage down below the minimum that these guys can stay running. So let's just go rebuild the vehicle again. There's some other kind of noise going on here, but first I want to see, did we get any other different codes? Nope, still the same one code. Go into special functions. Whoops. Gone. That's all it was. It's a bad spark plug. We can also go back, look at raw data. Nothing. So, have we fixed it? Are we done? Well, we're not done, because with these kind of problems, it doesn't tend to be just one cylinder. We just have the first cylinder to be affected by the problem. Unless you disabled active fuel management in the first couple of years of the vehicle's life while it was still under warranty, the damage to the piston rings is relatively permanent. The only real fix on these 5.3 liters for this oil burning problem is new piston rings. Regardless of what anybody tells you, what anybody says, that's coming straight from engineering at GM, right? That you need new piston rings. That's the only way to stop it from burning oil. So as long as it's burning oil, you're going to have problems like this. We're going to have to go through and do resistance checks on all of the ignition wires, just unrelated to this, but that's another problem. So we want to make sure that everything's to spec, and we're going to have to check all these plugs. So I'm going to go through this, and I'll let you know what we find. All right, guys, so this is what a GM ignition plug wire for this engine is going to be. A GM 1273, 1653, or an AC Delco 357D. Big box. You just get a new one of these and a little packet of dielectric grease, because that's a mandatory thing to be using. So we'll need to take our old heat shield off and put that on our new plug, right? And then we'll just cut the corner off of our dielectric. Actually, you know what? Before I do this, let me show you what the resistance measurement is on a brand new one of these. Let's slide this guy off again just so we can make sure we're getting good contact. So we said before that this old one, let's cycle this guy back on because he auto timed off. This old one we were getting 402 kilo ohms, and we said that we're supposed to get in this range per inch. If we take a look at the new cable, this guy, what are we reading on the new one? 885 kilo ohms, right? Whoops, I just let my hand slip. Let's get this back on there. Yeah, 885 kilo ohms. So more than twice the resistance on a brand new out of the box AC Delco ignition plug wire. That's what it should be, because if we look at the amount of inches we have here, we're looking at about, I don't know, about 5 inches. That would fit into this range specification. That's the minimum, which the old ignition plug wire isn't meeting. I can't really tell if the old one is OEM because there's no AC Delco or GM marking on it. And normally I'd expect to see like a little AC Delco logo or a GM logo. So I don't know. These may be original. These may be aftermarket. Not really sure. All I know is they don't meet specification, so they're coming out. So let's go ahead and get this guy reinstalled. Get this voltmeter out of here, and we'll come back in just a moment. All right, we'll use the dielectric that came with this because why not? So it's not meant to be a conductor. It's meant to be an insulator. And so we just want a little bit on the front so that when we push it through the plug, we get a watertight seal between the boot and the porcelain of the plug. So that's all we want to put in there. And similarly, when we plug it into the coil, we just want a little bit around the outside. We don't want to get this on the electrical connector itself. We just want to smear it along the coil nipple. And you can also just put it on there manually to that same degree if you'd like. Gotta have a stool to get up here and see this guy. Always want to feel that tactile click, and you want to hear that click. Like a double click out of that one. All right, so that's how we're going to do all of these. I'm going to go ahead and replace all of these because I just measured the number 3, and it also is not in specification, the number 3 ignition wire. So we're going to replace all these ignition wires so they're up into specification, and then we're going to continue pulling each of these plugs to see which ones have been affected from the oil burning. In the case of the plugs, we're only going to replace the ones that are looking negatively affected because this vehicle just got new plugs maybe a year and a half ago because I put them in there. There's another video for what we did that. So I'm going to go around, and if we find anything interesting, I'll show it to you in just a few moments. All right, so while we're running with that new ignition plug wire, I'm just going to come in here, rebuild the vehicle again. I brought this back inside, get it out of the hood environment where it's too hot. And let's just see what the state of this P0300 is right now. All right, so the last test is passed. So when we previously started it before we changed the wire, it's no longer experiencing this P0300. It hasn't run it for this cycle, but I'm pretty sure that we're going to pass it again. So that's, again, a good sign. And we'll just leave this code here, and I'm going to clear it out. It should clear out on its own. To check the service manual and see. If it's not an auto clear code, then we will come in and clear it out. I went a little bit too far. I meant to come in and see what our Misfire graphic is still showing now that we've got that new ignition plug wire in there. We're still clean. No misfires. All right, so now let's go ahead and get the rest of them done. We got 7 more to go. Like I said, having one plug wire bad, replace them all. That's my take. If you got one spark plug bad, depends on when you change the plugs. In this case, a year and a half ago, we're not going to change all the plugs. We're going to inspect all the plugs, and we're going to change any that look like they need to be changed. So we're going to go do that, and then we'll come back and show you where we ended up and what else we found with some of these other plug wires. All right, we're done, guys. I'll show you what we found in just a minute. Let's go ahead and rebuild the vehicle. Just want to make sure that we got everything plugged back in okay. And we get no self-induced misfires. Just want to make sure we're still clean. And we are. And then we're going to pop back out. And we should just have the same code still. And we do. Pass this test, pass the last test. So we're good to go on this problem. I'll show you here in the service manual that the P0300, all of these misfire type codes, still not sure why we didn't get the specific one, which is, again, why you need a scan tool sometimes to zero in. We got the random one, but we fixed it. And if we come over here and we see, I'm looking for what does it take to clear this code. Conditions for clearing the code. Here it is, conditions for clearing the code. So it's a type B diagnostic trouble code, which means it's going to clear itself. And if we go back to see about types, conditions for clearing, A and B, so the engine control module is going to turn off the malfunction indication lamp after 4 consecutive cycles that the test runs and doesn't fail. So we don't need to clear this. We're just going to leave it, have the owner let us know that it went out. It should just go out on its own as further confirmation that everything is fine. All right, so I think that's it. Let me take you under the hood and I'll show you what we found. All right, we're all done. We pulled all of these plug wires and they were all out of spec, so ended up just replacing all of them. And you get a set as a 1273 1654 or a Delco 748 UU. This will give you 8 of these rather than the single, which is what we thought we had before. All of these tested out in the ohm range between 880 and 980. So I think I had one of them, it was 992. So that was all within the specification for the length of these wires like we saw in the service manual. And one other thing I wanted to show you, a lot of these old boots are burned on the insulator. You see it's all brown. In fact, go on this side here. So if I pull the boot back, you can see, get in the light, you can see it's cracking and coming apart. And it's also got corrosion. That's rust. It's rust on this. So these are not GM parts. These are some kind of aftermarket thing. So that's why they're out of spec, and that's why their quality is pretty poor. So good garbage to remove from the engine. On the spark plugs, we ended up only having a problem with 2. So we've got number 1 that you already saw, and number 3, the one right next to it. I thought maybe we can set it over here against this light background. I thought it was close enough, but all the others had a very clearly defined iridium tip, and so they were okay. I mean, you know, I told you this is an oil burning engine, so you're going to have some evidence of that. But number 1 just really got worn off. And again, just for comparison, and by the way, you can get a set of 4 of these AC Delco plugs, GM 1941 7055 or AC Delco 41162. There's actually, at the time I'm doing this video, they've got a good rebate going on these, making them very economically priced for OEM gear. And if I put this guy right next to it, right, you can see there's that tip that's missing on these 2 that I was telling you about. So plug wires, proactive, that was a problem but not the problem. Fouled and burned plug, which is the reason for the misfire. Sometimes it doesn't have to be complicated. Sometimes it can be that simple. And then the one number 3 we changed proactively just because it looked like it was going to be the next one to suffer that fate. The others had very well-defined tips, and I did not feel that they were warranted replacing just yet. Again, this had new plugs just a year or so ago. When you're pulling these plugs, I try to use a tool like this Craftsman CMMT 98341, except for the number 1 plug because of that sensor. Then you can use a pair of hose pliers to grab that one because you really can't get this guy in there. But this guy's a lot nicer to the aluminum heat shields. And you probably will run out of dielectric like I did, so you can use an AC Delco 104064 or GM 1234 5579 to finish the job. The last thing I'll show you is, if we take a close look here, let me see if I can get over here where the flashlight can sit and help us. The problem with these modern trucks is trying to find something it's made of ferrous metal, so you can actually get magnets to work. So what we saw on here is all this carbon buildup, right? And ship all that off. That's what you're getting from the oil burning. And what I think happened to this plug, this carbon either shorted this electrode out or started to get it arcing way up into here past the ceramic. And that's why I think we eventually got the plug just not reliably firing, and that led to the misfire condition. But all of that is carbon from oil burning. So that was all it is. Sometimes it's something simple. It's not any, you don't need a new coil. You don't need to hit the fuel injectors. You don't need to do anything like that. Sometimes it's this simple. Again, could you fix the oil burning? Well, yeah, if you rebuilt the engine, put new piston rings in. What do you do in lieu of that? You do this. So anyway, I hope this helps you out, give you some tips on how to find something simple like this. Having a scan tool is almost a must-have on these modern engines to zero in, so you're not, shotgunning. You can doing a true diagnosis and zeroing into the specific problem. I'll put some more technical details in the video description, along with links to these part numbers if you are running into the same problem. If you got any questions or comments, go ahead and leave them below. I'll try to help. If you found this video useful and it got your misfire solved on your GM 5.3 liter, I'd appreciate you paying it forward and hitting that like button. And as always, thanks for watching.